Hello, all of you. I'm here again with Chapter 8 Motion of Class 9th, presented by E-Physics class of Fatima Convent High School, myself, Dipali. Now, in the previous video, we saw what is motion, origin, and position of the object and how motion is a relative quantity. You need a reference point to describe motion. Let us discuss this further for motion along a straight line path. Now, in this topic, you are going to come across two very important quantities related to motion. That is distance and displacement. We will understand the difference between these two quantities and how it is helpful in understanding motion. Motion along a straight line path. The simplest type of motion is the motion along a straight line path. Now there are various other types of motion as we saw in the previous part of the chapter that a motion can be circular, that is moving around a fixed point, may be rotatory, may be vibrational, oscillatory, or even erratic, that is a random motion which has no reference to any fixed shape. It can be in any direction. But we are going to discuss about motion in a straight line path. The simplest type of motion is the motion along a straight line. We shall first learn to describe this by an example. Consider the motion of an object moving along a straight path. The object starts its journey from point O, which is treated as the reference point. I hope you all now very clearly know what is reference point. Let A, B and C represent the position of an object at different instants. At first, the object moves through B, C and B and reaches A. Then it moves back along the same path and reaches C through B. The total path length covered by the object is OA or OC, that is OA plus OC, that is 60 kilometers plus 35 kilometers is equal to 95 kilometers. This is the distance covered by the object. To describe distance, we need to specify only numeral value and note the direction of the motion. There are certain quantities which are described by specifying only their numeral values. The numeral values of physical quantity is its magnitude. For this, from this example, can you find out the distance of final position C of the object from the initial position O? This difference will give us the numeral value of displacement of the object from O to C through A. The shortest distance measured from the initial to the final position of an object is known as displacement. Can the magnitude of displacement be equal to the distance travelled by an object? Consider an example given in 8.1 for a motion of an object from O to A. The distance covered is 60 kilometers and magnitude of displacement is along 60 kilometers. During the motion from O to A and back to B, the distance covered is 60 kilometers plus 25 kilometers is 85 kilometers. While the magnitude of displacement is 35 kilometers. Thus, the magnitude of displacement 35 kilometers is not equal to the path length 85 kilometers. Further, we will notice that the magnitude of the displacement for a course of motion may be 0, but the corresponding distance covered is not zero. If we consider the object to travel back to O, the final position coincides with the initial position and therefore the displacement is zero. However, the distance covered in this journey is OA plus AO is equal to 60 kilometers plus 60 kilometers is equal to 120 kilometers. Thus, two different physical quantities, the distance and displacement, are used to describe the overall motion of an object and to locate its final position with reference to its initial position at given time. Activity 8.3. Take a meter scale and a long rope. Walk from one corner of basketball court to its position opposite corner along its side. Measure the distance covered by you and the magnitude of displacement. What difference would you notice between the two in this case? Automobiles are fitted with a device that shows the distance traveled. Such a device is called as odometer. A car is driven from Bhubaneswar to New Delhi. The difference between the final reading and the initial reading of the odometer is 1850 kilometers. Find the magnitude of displacement between Bhubaneswar and New Delhi by using the road map of India. So, let us discuss these two quantities, distance and displacement. But before understanding these two quantities, we need to understand three important terminologies in physics. That is, first thing, physical quantities. What is the meaning of physical quantities? Now, physical quantity is nothing but physical property of any object or a physical property that can be measured or calculated or quantified. And it is expressed as product of numerical value and unit. Now, what do you mean by this? Now, we take a simple example of mass. Now, we know that mass means the matter contained or the quantity of matter present in any substance, which we studied in chemistry. Suppose if I take a cuboidal box or a block of wood and I put it on a balance which measures, say, 6 kgs, then mass is physical quantity, 6 is the numeral value, and kg is the unit. So, this numeral value is also called as magnitude. And kg is called as unit. So, any physical quantity is made up of magnitude and unit. Now these physical quantities are classified into two classes, that is scalar and vector. What does this mean? Now the quantities which require only magnitude for description are called as scalar quantities. But there are certain quantities which require magnitude plus direction for their description are called as vector quantities. Did you understand what is the difference between scalar quantity and vector quantity? The scalar quantity can always is actually only the sum of any magnitude, and vector quantity is addition or subtraction according to the rule of arithmetic. It can be positive or negative values of magnitude adding and subtracted. We will understand this in detail as we start learning the chapter further. Now, the quantities which require only magnitude for their description is called as scalar quantity, and the quantities which require magnitude and direction for their description is called as vector quantity. We take for example the scalar quantities are distance, speed, time, etc. Whereas vector quantities are force, displacement, velocity. Is this topic very much clear now? Now let us understand the distance and displacement. So, from this example which is given here, we can say that the object was at point O, it moved to point from O to C, then C to B and B to A, and then it is moving back along the same path. Now, if we talk about distance, we know that it is a scalar quantity and requires only magnitude, or you can define distance as the total path length. Total path length covered by any object. Say for example, there is an object at point O. It is moving along this line. It reaches point A, and the distance between point O and point A is 5 meters. From A to C, it is say 10 meters. Point B, it is 2 meters. From B to point D, it is 20 meters. Now the object moved from O to A 5 meters. From A to C 10 meters, from C to B 2 meters, and B to D 20 meters. So the total distance covered by the object is 37 meters. But we see that from O to A, the object is moving in a particular direction, say north, and this is south. Then A to C again north, C to B again north, but from B to D it changed its direction, and so the distance remains same, but displacement is a quantity which requires direction as well as magnitude for its description. It is a vector quantity and it is the shortest distance covered by any object. So you can say O to D is the shortest distance covered by the object, and that will be its displacement. Now we take the example here. The total path length covered by the object O to A plus AC, that is 60 kilometers, plus 35 is 95 because the object moved from O to A, that is 60 kilometers, from A back to C, that is 35 kilometers, that is 95 kilometers. But to measure displacement, the object moved from O to A, that is 60 kilometers, and A to C 35, but it is minus 35 because the direction of O to A and A to C is opposite to each other. And now if you add this, what you get is 35 kilometers, which is called as displacement. Did you understand now what is the difference between distance and displacement? So you can easily differentiate between distance and displacement. What could be the difference between distance and displacement? The difference between distance and displacement can be said as distance is the path length covered by object in given time. And displacement is the shortest distance covered by the object in given time. Distance is a scalar quantity. Displacement is a vector quantity. Distance is always positive and displacement can be positive, negative or zero as well. Did you understand the difference between distance and displacement? You can also say that distance is always greater than or equal to displacement of the body. That is, distance is always greater than or equal to the displacement. Whereas displacement can never be greater than distance. Never be greater than distance. In short, to remember, distance total path length, displacement shortest path length or distance plus direction is displacement. I hope these two quantities are very much clear to you now. So let us end this part of the topic here. Thank you.